Hello everyone, this is your video on graphing inequalities. So we're going to focus on a circle right now, and this is the ordinary and straightforward equation for a circle. X squared plus y squared equals r squared. And I could give you an equation that would be like this. X squared plus y squared equals 16. And you would know exactly what to do with that equation. You would have your graph. You would know that your r has to equal 4. You would know that it's centered around the circle. So I go 4, 4, 4, 4, and I get roughly a circle that looks like that, where r equals 4. Right? Everybody cool with that? Good. Now, what if I change this formula just a smidge? So instead of being x squared plus y squared equals 16, I instead have it greater than or equal to 16. In other words, what points could I put into this equation and have this statement be true? So, how do you handle an equation like that? Well, the first thing that you do is you pretend that it just says equals. And so you draw your circle like that. Now, since it's greater than or equals to, you get to figure out if you are also including all of the points inside of the circle, or are you including all the points outside of the circle? We know we're including exactly the circle because it's equal to that, and we still have an equal sign here. But what points would make it greater than 16? Well, in order to figure this out, what we do is a little bit of educated guessing. So I'm going to pick a point that's easy for me to calculate. And the point that I am going to pick is 0.00. Why am I picking that? Because it's so easy to calculate 0, 0. 0 squared plus 0 squared, is that greater than or equal to 16? Well, that would mean that 0 has to be greater than or equal to 16, which is not true. So the point, which is inside the circle, is not part of this equation. Therefore, all the points outside of the circle have to count. So I could pick any point in all of the universe. So an infinite number of points. As long as it's outside of this circle, it's going to work in this equation. You don't believe me, you say. Well, I don't blame you for not believing me. Let's pick a point over here. Let's call this point, what does that look like to you? For like 6, 7. Let's call it 0.67. Okay? 6, 7 should work in this equation, right? Because it lies outside the circle, and we determined that anything outside of the circle should work. Let's see. Our formula, if you remember, is x squared plus y squared has to be greater than or equal to 16. So in this case, our x value is 6, so 6 squared plus our y value is 7 of 7 squared, is that greater than or equal to 16? Well, I hope so. 36 plus 49 is certainly greater than or equal to 16. And so that point is valid in this equation. Does that make sense? Okay, now just so you know, if I had an equation that was x squared plus y squared is less than or equal to 16, and I picked 0.00, now I would have 0 plus 0 is less than or equal to 16, which is a true statement. So if that were the case, then I would be shading the inside of this circle instead of the outside of the circle. I hope that makes sense to you. Now, there is another special case that I want to show you about. So we talked about this case, which is if you have an equal sign. We talked about this case, which is how we pick a point and we determine if the equation is true. We talked about how we would do it if it were a less than or equal to, okay? What if this were the equation? Let's see, we'll start all over again. So x squared plus y squared is less than 81. Whoa! There's no equal sign at all. So what are we going to do? Well, I'll show you. What we're going to do is we're going to draw our graph. We know that r equals 9, right? Because r squared is 81, so r has to be 9. So we want a big old circle that has a radius of 9. But we're not including that circle. What? Yeah, no. We only want the points that are bigger than that circle. So we need to know where the circle is, but we don't want to count the circle in our answer. And so the way that we do that mathematically is we draw our circle using dotted lines. Yeah, like it wasn't hard enough to draw circles before, right? Now you have to do it with dotted lines. So this is our circle. We've defined it so that you can have a visual representation of it, but the dotted lines indicate that we aren't actually including the circumference of the circle. Okay? All right, so now we want to know which points satisfy this equation. Is it the points on the inside of the circle or is it the points on the outside of the circle? Well, let's just pick a point. And again, because I am a creature of habit, I'm going to pick 0, 0. So we would have 0 plus 0 squared plus 0 squared. Is that less than 81? Well, yes, it is, because 0 is less than 81. So the point 0, 0 counts. It's included in that equation. So I would shade everything in the circle, but not the circle itself, right? Because this is not less than or equal to, it's just less than. I hope that makes sense to you. All right, now we did these examples here using circles because they have such a nice little equation to work with. But you would do the exact same approach if you were using one of the other conics that we've been talking about. For instance, let's pretend that we are dealing with an ellipse. So our basic formula in this case is going to be x squared over 16 plus y squared over 25, and we're going to say that's greater than or equal to 1. Okay, so notice that very little has changed except this. Instead of being an equal sign, it's a greater than or equal sign. But we still have a 1 here. We still have a plus sign here. We know we're going to be centered over the origin because we don't have any messing with our x or y terms. All right, so let's draw what this ellipse might look like. I say it might look like this because I'm probably not going to draw it perfectly. We know that our a is 4 because a squared is 16, and so you take the square root of that and you get 4. And we know that our b is 5 because b squared is 25, so the square root of that is 5. So marking that, here's our center, and we have 1, 2, 3, 4, 1, 2, 3, 4 for our a value. And then for our b value, we have 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So we draw our ellipse, which is slightly longer north and south than it is east and west. And so we're good. All right, so now we need to figure out, we get to count our circle, our ellipse, because we have an equal sign here, so we are going to include that ellipse. I'm just going to make it look a little bit more elliptical. Wow, that is really one ugly ellipse, don't you think? Yeah, it's a good thing this isn't art class. Okay, so there's my ellipse. And I need to pick a point that's easy to calculate. So I'm going to pick 0, 0. Boy, am I ever boring, aren't I? So 0 squared over 16 plus 0 squared over 25, is that greater than or equal to 1? Well, here we would have 0 plus 0. Is that greater than or equal to 1? No, it's not. So 0.00 is not included in this equation. It would be all the points outside of the ellipse, including the actual ellipse, because we have that equal to point. Okay, so that is how you do that. You could do the same thing with a hyperbola. You first draw the hyperbola, and then you pick a point and you test it out. Now, before I let you go, I know that some of you are always looking for the patterns in math, which is awesome because that's what mathematicians do all the time. And so you might have convinced yourself, oh, if it's greater than, then it must be outside the shape. And if it's less than, it has to be inside the shape. You might be thinking that, but you cannot assume that all the time. Okay? Remember, I'm giving you easy peasy, little straightforward, nothing funky going on here. And you can't assume that. So just so you know, you need to actually pick a point and test it, because you never know when you're going to have like a negative sign that messes you up, or square root sign that messes you up, or, you know, something we haven't even learned about yet that messes you up. So pick a point, test it out. All right, that's it.